Question 4a, this structure here, the sulfuric acid structure, I've seen on 4 past paper questions in the last 10 years. It may have been on even more than that. The question, although it's on hydrogen bonding, is using a different format. So usually we have ammonia molecules or water molecules we see the hydrogen bonding in, but this is exactly the same. The marks come from the same things. The lone pairs of electrons on the oxygen, so here and here. A dipole between the oxygen and the hydrogen, so here and here, and then the third one, or the third marking point, is the dotted line between the lone pair and the hydrogen, so that connects them together with the hydrogen bonds. Sometimes worth 2 marks, sometimes worth 3 marks, but all 3 of those marking points are necessary even if it's only for 2 marks. For B, most of the things that you need are actually given to you in the question, so there isn't a lot that you need to do with this. You're told in the question sulfuric acid, you're told in the question you have HI, it forms, so that's your arrow, iodine, hydrogen sulfide, for which you should know the formula, and one other product. For this one, look at the atoms. We've got oxygens here, we've got no oxygens present on this side, and it's just using common chemistry sense, really, to try and figure out what the substance is that isn't included. Once you've got that, that would be 1 mark, and then your balancing comes for getting the 2nd mark. For C, again, it looks complicated, but the logic will always prevail. We've got conc-sulfuric acid used as a catalyst. An insecticide, B, so that's this substance here, can be made by the reaction below using sulfuric acid catalyst. We need to know the structure of compound A. This is reactant 1, if you like. Notice that there are 2 of these, 2 Cl joined to this benzene ring, and that is forming this insecticide B. Now, the problem that most students have is that they don't recognise that these that I've circled in orange, they are my 2Cl benzene ring constituents. The thing that I haven't actually accounted for is the part that I've highlighted in pink. So these come from here. This comes from compound A, as does the water. So if we break it down, we know that this substance here must be the backbone, if you like, of compound A. So in working out what the formula is for compound A, start off by just drawing this CCl3, which we've got at the top, joined to a carbon from here, and then joined to a hydrogen. So that's the backbone, in essence, of what we've got here. Then we need to figure out what it looked like before it was reacted. So obviously this can't be correct because we're missing bonds from these 2 sides of the carbon. So this here, as I said, is our backbone. We then know that we've got water that's also produced when we have this reaction taking place. So these 2 hydrogens and this oxygen must have been evolved when this reaction occurred. Now, the hydrogens, this again is something that students forget. The hydrogens must have been present at this point here and this point here before it was reacted. So the hydrogens are here. We can't see them on skeletal formula, so we very often forget that they were there. Those 2 hydrogens, one for the first one and one for the second one, have come off to enable the carbon to bond to each of these. So the hydrogens, we've figured out where they've come from. That means that the oxygen came from this pink structure in the middle. So the first thought is usually, okay, it must be an alcohol. We've got the backbone, we've got the carbon, we pop an OH on the bottom. But there's still a problem. What I've put here in orange, we're missing bonds. This carbon hasn't got 4 bonds, so it can't be an alcohol. So we need to think of a way that we have this backbone structure, that we have an oxygen, that we still have the hydrogen, but that this carbon is completely satisfied. So it must be, just working again through the logic, carbon 2 or 3 chlorines, down to the carbon, this carbon here, or this carbon here, and then double bond oxygen and a single bond to the hydrogen. So that there fulfills all the criteria. It matches this part here, and it has an oxygen in addition to the central pink highlighted structures. For part 2, sulfuric acid is a catalyst in many reactions. There are lots of answers to this one, but the most common one that we come across really in terms of an answer is that it is the nitration of benzene. Now you'll notice down here I've put must be drawn. That's because it asks us to draw the structure for compound A. That means a fully displayed formula. It wouldn't be acceptable to have CCl3, C, double bond O, H. So it wants the fully displayed formula.